We have a programmable ledger that you can program with a human being using what's called a Turing complete instruction set. Or with an enterprise large action model, you can tell our AI studio what process you want to automate in your institution using our ledger. Describe your objectives precisely, and the AI will generate the instruction set and test it for you, give you the documentation. And then after further human testing, you can inject that code into our ledger to automate the process. It's fascinating to me because it's a back to the future where you didn't have AI in 1970s, but you would write assembler code to program a microprocessor.
Hi, everybody. Today I'm excited to be able to speak with an old friend, Suresh Ramamurthi, who is an ex-banker, ex-chairman of a fund management company, a pension fund, and an astute technologist who's worked in the back offices of the banks. I've had this question at the back of my mind about how AI will revolutionize core banking. I think I finally found the man that has given me the answer. So let's get right into the conversation.
Manuel, thank you for the introduction. I also happen to briefly work at a company called Google as well. So that's kind of shaped all my thinking as well in a lot of ways.
Suresh, it's wonderful to talk to you. Today, I'm in Kosovo in Serbia, or Kosovo next to Serbia, depends on who you're speaking to. And you are in Miami, in your home. Yes. So I want to get the definitions right first before we dive into what we need to discuss about how AI is revolutionizing finance. You are a former Google executive, having built and sold technologies. You were at one time chairman of CBW Bank in Kansas, and the chairman of Kansas Pension Fund. So you come with a lot of depth in experience, both on the fund management as well as the banking industry. But at heart, you're a technologist. So just tell us a little bit about your background and and what has brought you to where you are right now, which is the founder of NetXD. And then explain to us what NetXD does.
Emmanuel, thank you. So my career, I'm an undergrad in electronics and communication engineering in India from one of the oldest colleges, College of Engineering, India. I ended up pursuing a PhD in the US in hypertext theory. My thesis was very similar to what Sergey and Larry did at Google, except I wasn't as smart as them. So I missed the connection to the future. So I was a little early as well. I was a couple of years before them. And I focused on wireless data and hardware, and I had a couple of companies in that space. Later on, I did an MBA at the University of Chicago, and Google recruited me, and I was quite surprised because I thought I would not be a good employee. But I was very curious. At Google, I wanted to understand, they are a company that had a 300-year business plan that talked about indexing all the information in the world, and they were using hypertext theory to do it. They were tokenizing all data in the mid-90s. So I spent some time. It was quite fascinating for me. And then I later on left to be part of a group to buy a bank so that I could understand the nature of money, because money is the most fundamental invention of human beings. It allowed us to innovate rapidly. It accelerated innovation because you could now pay for things. It created you had an exchange of value. Then you also had a store of value that, in my view, also amplifies all the basic sins, right? So money is an amplifier as well. So my journey in the bank was, we launched the first banking as a service in 2014, very early. I learned that the middleware approach is not the right approach. Later on, many years later, I started NetXD because my son kept telling me in 2009 to mine Bitcoin, and I didn't. by 2016, 17, he was telling me how stupid I was for not having done that in 2009, because it would have paid for his college when he went to college 4 years later. So that kept bothering me, because I said, this kid knows something I don't. So I started to explore the immutability of ledgers, the DeFi that we call distributed finance. And I explored the algorithms, and I found that there were algorithms that were open to all human beings, owned by no one, unlike RSA, which you have to pay a license for RSA. The concept of zero trust came about. The concept of immutability came out, and that is what powers the blockchains. And I realized I was absolutely fascinated by those algorithms. And I decided that next time I build anything, which I did at NetXD, I will use those to build a natively zero trust platform where everything is digitally signed. And every transaction is digitally signed. But every non-financial transaction is also signed with a digital key, just like in using a similar structure to the one. So that led me to NetXD, which is essentially now a world's first enterprise large action model company. It has a programmable ledger and running in over 10 financial institutions now. And the newest version, you can think of it like how the microprocessor arrived as a programmable chip during an era when every other chip was static and functionals focused in the 60s and 70s. We are at that moment now. We have a programmable ledger that you can program with a human being using what's called a Turing complete instruction set, or with an enterprise large action model, you can tell our AI studio what process you want to automate in your institution using our ledger, describe your objectives precisely, and the AI will generate the instruction set and test it for you, give you the documentation. And then after further human testing, you can inject that code into our ledger to automate the process. It's fascinating to me because it's a back to the future where you didn't have AI in 1970s, but you would write assembler code to program a microprocessor. And then along came a gentleman called Bill Gates with a DOS operating system that converted other things into assembler down to the microprocessor. So that's where the enterprise large action model is, where you can describe what processes you would like to have automated, and our system helps you do that. That's why it's called action model. You're just not talking to you, it's getting it done.
Is that a terminology that you created, or is that in the science fraternity?
The terminology is less than 60 days old or 90 days old, in my view. There is another company that does this for consumer applications, where you can tell, it's called Rabbit, you can tell the Rabbit device, get me a pizza from that pizza shop, and it will connect to your Uber or whatever, Swiggy or whatever app in your country is, and it'll order, and it's just an integration of various things. It'll order that and bring it back. So that's where we saw the word phrase, large action model. It perfectly explained what we did in the enterprise.
Okay. How's the enterprise large action model differ from Ethereum's DAO, for example, or any other model in activating, bringing the ledger to life? So
if you take the Ethereum, they're an open source, absolutely transparent model, which they also have a Turing complete smart contract capability, which allows you to do various kinds of, they're essentially what you would call a programmable web, right? What we have in a programmable ledger is we have all those capabilities and a lot more than that. The reason is enterprises have laws to abide by, right? So you have to have KYC enforced. You have to have operating controls enforced. You have a very structured set of things, endpoints that you have to manage in an enterprise. So our ledger is very focused on operating within an enterprise. And we have consumer protection laws that don't allow you to share data to the rest of the world like you can in Ethereum. So you have to follow all the existing processes and procedures for security, privacy, compliance. All of those are embedded. The one thing that we have very clearly that none of the blockchains have is real-time data analytics at 360 in all directions and derivatives of those. We call it a data sensor architecture. Our system can understand everything in real time, and then that can trigger actions. And we can trigger actions that are outside of our system, can call the external world directly. It is not easy to do that outside of the Ethereum world. The Ethereum smart contracts have to be monitored from outside to trigger actions outside. So there are some limitations in our view on those existing blockchains.
So when you say it can trigger actions outside, how is your enterprise large action? Where does the programmable ledger sit in your architecture? Because I come from good old-fashioned core banking systems, which are linear and they are stacked on one on top of the other. And here, what you're saying is that the ledger is now a living, breathing thing, and it can produce its own code. It can respond to external factors, and I assume that the AI can help the ledger learn as well.
You're absolutely right, except we are not letting AI into the ledger today. We're letting AI sit away from the ledger, write the code to configure the ledger, have a human being test it and put it into the ledger. So there is still a little bit of a separation between the AI and the ledger. But can we pair the AI into the ledger? Yes, we can. But I think that's a few years away for human beings to get comfortable to do that. Right now, I don't think any enterprise is comfortable to let AI in the ledger. So we keep the AI as a separate AI studio today so that it can instruct. It's like, take the 1970 microprocessor analogy. It's like having a human being write the code that is then put into the microprocessor after testing.
Okay.
Human being, and that human being listens to one more human being who tells this what they need in the microprocessor. Instead of the second human being to write the code, we have AI to write the code.
Okay.
But now that is going to change rapidly.
Why I was excited with your programmable ledger model is that I've been asking this question: what will AI do to core banking systems? And core banking systems are by definition, as I said, hierarchical. They're also siloed in that the data sits in multiple applications, product sets, and so on. And how is your model revolutionizing what used to be core banking systems?
Very simple. Let's go back to history, right? If you take the 60s and 70s post-vacuum tube era, you had static functional chips that were assembled in a circuit board. And when you needed to change the function, you need to put in another circuit board. Once a microprocessor came, then you stack many circuit boards, just like how you have many stacks in a core banking. Once the programmable microprocessor came in, you really eliminated all those stacks, and the microprocessor started swallowing and eating up the nearby chips in functionality. And it also connected to the endpoints, the USB port today, serial port in those days, parallel port, Ethernet cable later on, then Wi-Fi, which, if you really think about, if in the enterprise world, they are payment rails, right? It's like payment through cards. Those are all endpoints that are absorbed and managed through a programmable ledger. You don't need separate applications for each one of them, because everything that you do in an enterprise can be expressed in simple process flows. And if you have a system that can handle it, and it's already doing it, this is not a pie in the sky. This is a real product running in 10 plus institutions today. The programmability is not fully used by them. We configure it for them today. But tomorrow, they're going to have an AI studio that allows them to test and configure it themselves, so that they don't have to spend a lot of money on another application that sits on top of that. Then they have to build an ETL between those two. Then they have to do the entire management network between those two. All those goes away. There's nothing new. It was the same thing that happened between 1960s and 70s. where each board had to connect to the other board. They had to connect wires. It was a mess in the building, and then along comes microprocessor, and they all go away. So you're going to see the same thing happen. Now, how is it going to happen? That depends on which bank is willing to grab the land first. Right? We have some banks. We have one that has grabbed it and has already gotten, as I told you, I can't name them, but they've already 15 to 20% market share in the country in 3 years. And now they're entering another country. So we think what will happen is institutions that go first will be able to grab more land or market share, right? Those that want to wait and see, this is not a wait and see opportunity, because this is one of those things, if you wait and see, you lost the opportunity already.
Yeah, when you say grab market share of what? Deposits?
Of your customers. Once you grab market share on the mind share and the market share of customers, you're going to get their deposits, you're going to get their loans, and you're going to get them to be sticky with you.
Yeah, but what do you mean by grab market share? Customers opening new accounts very quickly?
Yes, they come in, open new accounts. That's what happened in one of our customers who implemented a platform. He was able to take market share away from other operators in the market because they had better onboarding through us. They had a better user, delightful customer experience. They had absolute security with zero fraud issues. Right? Their operational cost went to near zero in many areas because we are very big on settlement and reconciliation. Right? Reconciliation are the most important things in a bank. If you want to start your day with no reconciliation hangover, your previous day should settle correctly. So when you have all this good hygiene in the system, and now you're adding programmability to add more and more new features, we can respond rapidly to market needs. So they went from zero market share to almost 20% market share in 3 years.
Okay. When you add all these functionalities, how does it perform as a transaction system? Because, for payment, for trade finance, speed would be an issue.
So inherently, our data analytics is what's called order of one, O of one, which means it's a way to express time complexity algorithms where even if I expand 1 billion times more, the speed at which I can access information in my system is constant. It is very similar to what Google has achieved. As you know, Google today is handling 1 million times more users than it did 25 years ago. Yet the speed is instantaneous. So it's called order of one. So you achieve that through a certain types of algorithmic design on one side. On the other side, where you have to deal with external parties, you are limited by the speed at which they can take data from you. When you're connecting to external pipes, the amount of water you can send through or oil you can send through depends on the other party as well. So there we are limited by other parties. But within our architecture, we have already checked in thousands and thousands of TPS. We can easily cross 10,000 TPS. So I don't think we're concerned about transaction processing because that was built in from scratch. We designed the system for 1 billion corporate accounts, 10 billion human being accounts, and 100 billion machine accounts. So we think there'll be 100 billion machines that will soon be available that need to be instrumented and connected to a platform.
Right. And these machines, are they configured like a cloud or in a structure?
Every machine is coming alive, right? Today, if you notice, there is a mobile app that connects your speakers, that connects your laundry machines, that connects your oven, that connects your blender, right? Soon your drinking glass will be connected to know how much you drank, right? There'll be sensors in every one of them. So even 100 billion devices may be a small number. The way we look at that is we tokenize everything natively. So there are many types of the tokenization of payment methods. There's tokenization of every word. That's what Google pioneered. So we do that as well. We tokenize every data element that comes in, right? Then there's tokenization of assets, where you represent a dollar or a pound or a Singapore dollar in a digital form against the original somewhere else.
When you say tokenize, do you mean digitize? Do you mean tag, or is it really tokenized? In other words,
it's a digital representation. There are multiple types of tokenization. So a digital representation of a financial asset is one type of tokenization. Data element level tokenization is where you take a word or any fraction of a data coming through the system, like a payload of a transaction, tokenize every data element like LLMs do, or LLMs read those tokens, right? You tokenize those as well. We have been doing that natively, right? Then you have tokenization from a security point of view for Visa, MasterCard. So we do all of those. So you have to, there's no future without tokenization. And we do it natively. The programmable web does it as well. Essentially, it's a digital representation of an asset from an asset tokenization point of view. Now, if you tokenize a machine, there are two things you can do. Either you can build a connector to a machine so you can control the machine, or you can tokenize the machine. You can do both, because tokenization saying I own the machine is in my asset, and I'm able to turn it. I'll give an example. Let us say you're a manufacturer of kitchen ovens for restaurants. And we can tokenize the devices, and we can even put in a GPS controller and a controller into the oven, and they can lease it. And the thing will be connected to a ledger, so you'll know that where it's being used, how it's being used. And if they don't make a monthly payment, our system will be able to turn off the oven from working in the restaurant until they make the payment. That's a good example of how you manage. You really don't need to connect to the oven with a connector to use it every day, but you need enough to know what is going on for a lending purpose and turn off the machine if they don't pay. And imagine that kind of lending where manufacturers already have the ability to integrate that to a ledger like us. And you can, as a bank, lend money to finance whatever it is you buy, right? Could be an air cleaner, could be a speaker, could be a TV, but then if you don't pay, the TV comes up with a message saying, you need to make this payment. Would you like to make it right now from on the TV itself?
Right.
Scan this QR code and make a payment so that I will show you otherwise I'm just going to be showing you so you're going to have a kitchen oven that is tokenized and controlled for the sake of lending. So you will see the ability to finance anything look, this is not new. In the US, you have cards that you can now switch off if you don't pay your monthly payment. Same concept, except it's a standardized way of doing it for every object in the economy.
Right. So where does the data end up sitting? It seems that you didn't. You avoided answering my question because in core banking systems they sit in silos. They're
We don't
tagged.
have a silo. We, as I said, we have a data sensor architecture. All data is parsed. We do, as when we tokenize the data. For example, OpenAI creates roughly, I don't know the exact number, something like 1,300. Each token is represented in 1,300 dimensions. They call high dimension representation. We represent an average banking transaction in about 160 dimensions. We have 160 derivatives, or what we call data elements, tokens we derive out of that. So the high dimensionality allows you to precisely understand a transaction. Instead of representing a point in X, Y, Z and time, you're now representing using 160 dimensions in our platform. OpenAI does it with 1,300 plus dimensions. So that's kind of the architecture of the data. The data is sitting there highly measured, highly tracked, tokenized.
So the bank can choose to locate its data anywhere.
It doesn't matter. They can run it on any cloud. They can run it on you can have a cluster of Raspberry Pis, which no bank will do, but you can run it there as well. So we are not tied to a cloud provider and say we use the cloud provider's fill in the blank service. We're not doing that.
Okay. Now, any bank that's talking to you, how hardware? What it sounds to me is that you're energizing or you're bringing power back into the hardware, or rather, you are deriving the power of the hardware to be able to do this amount of processing, right? So, what is the hardware commitment of a bank that works with you?
Actually, we are able to run this today without the AI Studio, which obviously requires hardware. The regular programmable ledger does not require anything extraordinary in terms of horsepower. It is normal. It's actually more efficient because the number of layers is minimal, right? It's fairly efficient, right? The AI Studio, portions of that require real-time AI responses. If you do the conversational side of it, that's going to require GPU-enabled hardware.
So none of your 10 banks are building their own learning models, their own in building their own LLMs in a way?
I don't think so. I think we are doing it for them because as our LLMs are learning our own microservices, it took us some work to get it to focus. AI is still a new field. So we were able to teach a particular LLM to learn our microservices, to learn our available services for online banking. The most fascinating thing for us, while it is the real value is in automating middle and back office because it drives costs down, but the most visible portion is the customer interface. And that's where you need more and more AI power. And the customer interface, we learned that is going to go the way of the UIs in 1995. If you remember, in 1995, every application had a custom user interface on Windows. You had to run that application from a floppy disk or a 3.5-inch disk or 3.25-inch disk was put in, and you ran the exe file, and it came with its own whatever. Along came the browser, and every application you could run on the browser now. And all the UIs were browser enabled. Guess what? That browser is gone. All UIs are just one box that you type something or what you want to do or what you want it to display for you, a dashboard or whatever. It does it on the fly. Or you're going to converse with it on your phone or on a microphone or even on an Apple Vision Pro. And you're going to gesture. And that is your UI. And we found this UI to be far more efficient because it understands what you want to do and precisely guides you to exactly what you want to do and make sure that you're happy that you got the task done that you wanted to do. There's no distraction. You're not looking at 15 things in a menu.
So there's a lot happening on that front where there are many things for banks to reimagine. The first thing they need to reimagine is the core banking architecture. The second thing is the customer interface. In a way, it doesn't matter anymore what that interface is. You are able to read data that is being generated and respond to it, and it doesn't need to be delivered to you on a platform or in a certain format. In that sense, this AI-based programmable ledger is agnostic to how the data is configured and how it's delivered to you.
Yes. Now let me throw one more thing in the works since we're talking about it. In about 5 years, I would guess all of us will have a personal AI. We will instruct our personal AI to go to the bank and make a wire. So at that point, your personal AI has to talk to the bank's AI and exchange security credentials, which you will approve from your phone. And you would have instructed your personal AI, say, yeah, I need to send money to XYZ to make the payment on a personal basis, not a business will do it differently. And your AI will translate that into some fashion, some interface into the bank's AI and get it done and come back to you and say it is done. Okay. Today, we are providing the AI interface. But my view is this itself may be only for 5 years. Because ultimately, you may have a personal AI assistant that does everything you want to do, including your banking. Not for a business. Business is a different story, the way they would do it. From a consumer side, you will already have a personal assistant that does anything you want, right? And they will that assistant will even talk to your bank. The banks that provide the interface to enable to happen in a highly, highly secure fashion are going to see more rapid adoption because you're going to say, I don't want to use this. I already have mine. If you connect to mine, I don't have to really think. I'm bicycling in the gym and I say, make that payment because I am late. It happens. Or you say, apply for a loan, whatever it is, your AI checks everything, gets it done. So that is coming in 5 years or less.
Yeah. In fact, today, and this is where in decentralized finance, all of these are already available, on crypto, on tokenized assets.
Because they have the algorithms. The reason it is possible is,
once again, you can talk to any algorithm. Doesn't need to be a specific bank in that regard.
Yeah,
and that
so
means
you need zero trust keys. You need digital identity, and you're able to do that is simply because you still have to authorize on the crypto world with a private key, without which you will lose your money there. In our case, you lose your key, you will replace the key, you don't lose your money. That's another problem you have with Ethereum, is you lose your key, you lose your assets. It doesn't work in the real world. You cannot lose your key, right? Therefore, people park their keys in an exchange, and the exchange has your money now, which is the same as you putting your money in a bank. So yes, you have a DeFi world, you have crypto, you have all the features, but at the point of security, you delegated it back to the real world. And those people have trusted with keeping the keys and never losing it, right? In our world, the way we design for enterprises is, yeah, the key is great, but you lose the key, you don't lose your money. We just have a different way to get you back another key without losing the assets.
Okay. Now let's let all hell get loose and discuss the applications as they're going to evolve over time. Banks are already talking about tokenized deposits. How would that evolve on your platform? I guess it takes the banks and their customers to where we've just discussed, which is the user interface, the programmability, and so on. Where are the banks, like the 10 banks that are talking to you? What are their initial pain points and case studies that they are engaging you with on in order that they can revamp the entire architecture eventually?
So I'll talk about a real use case with one of our banks in the Middle East. They've crossed hundreds of thousands of wallet or consumer users now. And they said all of them get their payroll through us, through their institution. They said, how do we provide them a wage advance? Right? Like in the US, you can borrow against your next paycheck, salary advance. And they were contemplating buying another software to them. They said, no. We'll just write a script for you and program it. It's as simple as that. Because we have a data sensor architecture, we already know all the statistics of every user. So if you want to do a salary advance that says, I want to loan up to 40% of their last 3 months average paycheck to them now when they request, and collect the money back in the next paycheck, it's just a script for us. And then you can also decide how much fees you want to charge. And with that script, they're going to make another $5 to $10 million a year. There's no need to roll in a new application. And it's contextually configurable. They could do this for this kind of loan, that kind of loan, right? So that answers your question, how the banks are contemplating it today. There's another one doing similar, something to do with contractor loans and so on and so forth. Now, going back to the tokenization side, the same bank that is looking at this use case says, I'm now opening I got a license in another country. I want to enable P2P transfers between two countries. But I have a headache of settlement in dollars, but my countries are in two other currencies, and I have to do the swaps back and forth. We said, you're already tokenized assets. So create a third token that is equivalent of a stable coin among yourself, which is an internal stable coin, and then use that as a marker to transfer money and net settle once a day. It's a great use case of tokenization for intra-institution, multi-currency, multi-country payments, and you get to keep the float without actually having to trade FX. No, you're only using notional FX values to charge each side, but you never exchange the money, you only net settle on either side, right? So they're going to make even more money in that. Now, similarly, if you take tokenization on the trade finance side for a large bank, like JP Morgan is doing one, when you have a large bank and you have a correspondent banking network, there are so many use cases. You take India has a wholesale CBDC now. I believe at some point, and India is also simultaneously upgrading all its ports and digitizing the port infrastructure and the rail infrastructure and the trucking infrastructure, where now you have APIs to see when a ship docked in which port and which goods were landed and cleared customs. Previously, if you had a trade finance, you had to wait for the paperwork from the port manager or somebody to give it to you, and then you have to rush it to the bank and the bank manager to verify that before they would release the money to you. Today, with the APIs, with a platform like ours, you would instrument those, you'd call those APIs, and if the trade finance is running on our platform, the trade letter of credit would be funds would be released here, or we'd be able to call an API to the wholesale CBDC that Indian government has, the Reserve Bank of India, and release the funds through that. You've now made it zero ops. There's no human being involved anymore because the government is providing infrastructure in case of India. I'm sure UAE is going to do that. I'm sure Singapore is doing that if they're already are going to do that if they're not doing it. You're going to see, especially countries like UAE and Singapore, they have to do it to be very competitive in the market.
Yeah. So your product, so to speak, or your application is the mother of all applications in that you don't need to do application development after this.
No,
because everything is being used.
Go back to the microprocessor. Once you did the microprocessor, you just wrote code in assembler. You didn't really need those extra chips that are functional chips anymore. You don't need them anymore. That's why I built this.
Yes. Now, the token aspect of it, would you help? Do you have a module in there where you can actually build a token for your bank? Because I think
I wouldn't call it a module. It's native. We natively store it as a token anyway. We just don't tell you until the day you want it. Then we say here it is. So it's already tokenized.
So some forms of tokenization includes offline tokenization, peer-to-peer tokenization. In other words, there's no audit trail anymore. That the token is real. Now when that happens,
offline, we're not doing offline at this point. But what we are enabled is we are connected. We have connectors to multiple blockchains, so you can take something there and hold it here, custody, or you can token it here and issue a token on the blockchain for use within the ecosystem. So you can do both. And one of our investors is Stellar Development Foundation. So we work with them to create these things on Stellar as well.
Right. So then application development, your end user can develop his own, his own script and interface with you or with the platform that you've created.
You're absolutely right. This is called the revenge of the business analyst, right?
Okay. Yeah.
When the hardware guys made the microprocessor and made it easy, and Mr. Bill Gates built the operating system, among the first ones to build, it made the hardware guys commoditized, and the software guys have reigned in glory for the last 35 years. Right now, what is a software coder or engineer? Is somebody who translates from what a human being tells them as a business requirements into code that the computer can understand. But the computer is now saying, "I understand you, human being." You don't need this software coder. You just need to be very precise in telling what you want. So your precision becomes important. So the more precise your ability to explain what you want, the more usable code you're going to get out of the computer, out of the AI. Right.
And what that also means is that all of the interactions, all of the conversations between the customer and the institution is now, taggable or,
it's fully tokenized, fully tracked, fully understood.
And fully processed, which is...
Yes, it is. Because we don't distinguish. We don't distinguish between financial, we call them financial versus non-financial transactions. Financial transactions that move money. Non-financial transactions are everything from inquiries to balance inquiry to checking your beneficiary history list to asking a question. All of them are tokenized.
Right. What other institutions in that space that you're in at the moment? You mentioned Rapid, which has got a consumer-facing platform. And then there's you, which is more like revolutionizing the enterprise architecture. So, who else is out there doing what you're doing?
I've heard that Salesforce is experimenting with scripting and large action models on the Salesforce platform, which like they should. But in our view, it's going to be very hard for Salesforce to do because they have to retool their entire platform in a zero trust basis, just like the programmable web. And how fast can they do on their existing platform is something I don't know.
Okay. So any institution with a large amount of transactional data would be tempted to move in your direction.
Yes.
Right. Now, what are the traditional core banking vendors saying? How are they reacting to this programmable GL?
We have not talked to them. Many of them, I don't believe, will understand. We've looked at the presentations by some of the major ones, and they all have an AI initiative, but it's mostly about, I think many of them are rebranding business intelligence as AI or machine learning as AI. Because I've seen AI for credit scoring. That's a rule-based scoring. I don't know why you need AI for credit scoring.
Well,
some
if you have AI for credit scoring, you're agnostic about the data. You tag the data, right? And you credit score. You don't even call it credit scoring, because credit score would imply that the data that you collect is credit score data. But
as you said, a lot of the AI, so-called AI use cases from the traditional legacy core vendors is either rebranding their existing efforts in business intelligence or big data as AI, or is applying AI to cleaning existing data such as ETLs, such as OCRing documents, or using it for call center management of calls where AI answers the call and routes it to the right person. So these are peripheral use cases that are nowhere near solving the architectural mismatch of the traditional core. Let me put it this way, there is no way that a core that is based on technology designed in 1970 or 80 or 1990 is ever going to be ready for real-time platforms with AI, data tokenization, and zero trust. It's like saying, I have a car built on the Roman chariot, but I'm going to attach a jet engine to it. It's going to fly. It's not going to fly. It's going to break into pieces.
So when you say zero trust, how does that impact the way in which KYC compliance and even onboarding of customers?
It's a most powerful tool I've come across so far. What is zero trust? End of the day, it is basically, let's take one of those algorithms, elliptical curve digital signature algorithm. It is like in a Bollywood movie where toddlers are separated at birth, but they remember their mother's lullaby. And 25 years later, one sings one, the other one can verify that has to be the twin brother. That is a simple example of a ECDSA algorithm. But imagine that being done asymmetrically, asynchronously. So every time you touch something, it's digitally signed. There is a signature set of zeros and ones attached to that request for balance inquiry or that request for a transfer. That set of digits is available for the rest of our time the universe is around in zeros and ones, that using a public key, you can verify only Emmanuel could have sent that. Nobody else. Because only Emmanuel has a private key linked to his biometrics. That is called zero trust, because you can then verify it, and every time the data jumps through your enterprise from one part of the enterprise to the other, you can re-verify saying, oh, it is Emmanuel. And Emmanuel is allowed to go here, is allowed to see this, is not allowed to look at this. This data is locked. Only Emmanuel can approve it. That is zero trust, which means you don't trust anything until you keep verifying it repeatedly at all places. It's like having an ID to a building to enter, but you're measured every 10 feet, you're checked again to see if you're allowed to go through this elevator or that elevator. You can't go where you're not allowed to go. And you get to the floor, you're only allowed to walk into the room and sit in the chair you're allowed to sit in. That is a great example of applying zero trust to somebody walking into a building, as opposed to once you're in the building, you can go anywhere you want. That is not security. You can go anywhere you want, So that is how traditional systems are built.
Right. And you're able to do constant monitoring because the data is tagged at source.
Yeah.
You call it tokenized, but it is a form of tagging in a way. So
it's more than tagging, because what you do is you also had hashes to it, because let's take an old example of a government office in 1960s. When you go in, somebody hits a stamp on your document saying you're entering. Then you go to one portion, the guy stamps saying, I have approved this. Then you go to the next fellow, he says, no, I'm the second approver. Third guy says, here is your whatever he came for. Everybody's put a stamp on it, right? To leave the building, you have to show all the stamps or to pick up something. It's like that. Everywhere you go, there is a signature being added if they do some other action on it. So we have an audit. We have operational transparency because you have process visibility everywhere, what is going on. And all of them are happening very, very fast.
Suresh, you've explained the technicality of it very well. And I've been, rather reticent as I was listening to you because I wanted to make sure I get all the facts right. But what you have described is a revolution in enterprise-wide, customer management system, if you want to call it call it for what it actually does. But what it does is far more than that. It's actually a living, breathing GL. I mean, that's how I would explain, or I would describe.
That's where it's going. It's going to become a living, breathing GL, where if you were to apply our GL to the Web 3.0, our GL in a Web 3.0 use case will know all your assets on every blockchain. It'll be able to talk to smart contracts. It'll be able to make payments for your suppliers with your approval. All of that will be instantly done on stablecoin. Well, all those things can be done today with a ledger on a Web 3.0 use case. And there are about 1 million Web 3.0 companies we believe will soon start looking at our ledger as we announce it and let them play with it. But you got it right. But that is the gold standard for today. And we all have to get there from a regular enterprise because this is the 4th industrial revolution, maybe the 5th one. Imagine we are now at a point where the collective intelligence of all human beings in words is available to every human being instantly, right, with AI.
Right. Now, what would you say about the criticism that your system may not be scalable?
Well, the criticism so far has not been an issue because it has been scaling very fast and very well. We have now 4 billion tokens of data, and it's still not even moved out of first gear. So, because algorithmically defined. See, it's not that we're bragging or anything. If you design it so that you know your O on one side, other side, you know that this is the finite amount of time it takes to compute this, and you're trying to use algorithms to be more effective. For example, one way to have an efficient system is to use math algorithms instead of if and then loops. So you have to code in a way that Google does it really well. You precisely translate something into an algorithm wherever you can.
Yes. I'm talking to several people who are at the frontier of Web 3 as opposed to Web 3.0, because I do make a distinction that Web 3 is is a blockchain model, and Web 3.0 is Tim Berners-Lee's activating the platform or activating the browser-based platform. So what you're doing is really more Web 3, and it's such early days, and yet it's very promising. Now, there was a period where there were new age core banking systems that promised to get digital banks off the ground very quickly, and revolutionize the GL and so on. What was that all about? You seem to have leapfrogged that generation and moved into a whole new dimension. Will these intermediary players be able to scale and replicate what you've built?
So let me answer this way. I didn't leapfrog. I built one of those in 2014. I launched the world's first banking as a service with a middleware, like these guys are doing today, right? And I realized very shortly that was not scalable. That was not the right solution. And that's when I went to this approach. I said I abandoned that. I didn't stick to it. And the reason is as follows. If you go back to the root original design of every enterprise system that is operating today, you'll be able to trace it back to 1960 to a language called COBOL. It's not the language, mind you. Admiral Grace Hopper invented Flowmatic, which then became COBOL in 1960. And at that time, everything else was done on books. So the very first coding, they just represented the book in the mainframe. If the book wrote things like this, they did similar things on the mainframe. So the computer became the record keeper. So the constructs of an account, there was no real construct. The concept of an asset, they were all just numbers and text, right? And subsequent systems, for the sake of backward compatibility, followed the original design even to date. So do all these new age core banking systems. We threw those out and said, today you have to build it as a natively tokenized in a programmable container with a data center architecture, with tokenization everywhere. Everybody else builds it based on that 1960s, like building a car today on Roman chariot design. You have much better materials today to build a car from. That's what Elon Musk did with Tesla.
Yep. And therefore, your architecture doesn't look anything like, what the traditional GLs would look like, evolving. This has been a fascinating conversation. It's also technical. If everything that you say is true, it revolutionized how a bank builds its interfaces with customers. Throws out this whole application development approach and focuses on algorithms and activating the GL. And then, as you said previously in the preparation, the conversation that we had in preparation for this session, the business analyst takes over, and the programmer sits in the background, basically.
No,
so
the business analyst takes over once, because the AI learns and builds a reusable library of modules.
Even there,
So, even there, the business analyst gets freed up to do the next thing. And if he or she is not the domain expert on the next thing, it's a different business analyst, right? So we are in a very different cycle right now. We are talking after 10 plus, we actually more than 10 institutions using us. And we are quite surprised because we don't talk much. We just make it happen. They're happy. It doesn't fail. It keeps running well. And we have only gotten customers through word of mouth. So which means each customer says, I recommend this to somebody else I know, go talk to them, right? To us, we needed to see that for the first 10 customers or more, right? That gives us a sense that, yeah, this is something that works for us. So we really appreciate this time, and we're happy to have you see the platform in live in any of our clients, and also share the reports we have that you can look up as well, and even talk to them if you want. So,
in fact, let's list some of the reports that talk about this new dimension that you've created, and what else exists out there. We'll put that on the in the links below. It's been a fascinating conversation. It adds up to how I'm looking at, where the breakthroughs in Web3 technology will be. In everything that you've said, it firstly energizes the relationship with customers. Secondly, it enables customers to personalize their relationship with the institution. And thirdly, the sky is the limit in terms of productization and a whole range of new meaning that can be deciphered from the conversations, from the transactions themselves. Have I described that correctly? Because that's
right.
what I think I'm seeing.
All information is going to be useful and will be used because they're all tracked now, right? And ultimately, what I feel is every customer will be treated like a king. It will have highly personalized service. It may not be from a human being, but it will be from an AI, right? But they will enjoy it. It will be highly personalized. They'll never get angry.
Yeah. So Suresh, I see you as a man who has revolutionized core banking. The other conversations that I'm having are with a financial institution that is Web3 native, and a non-banking financial institution, that is going into tokenized assets on the business front. And if I put all three of you together, I think the future is already here, and I can already see the future. So I'm very excited. Thank you for this conversation, and let's have another conversation as the body of knowledge evolves and new breakthroughs come about because your clients are using your platform.
Manuel, thank you very much for the opportunity. It has been a long road. It is 15 years since I started in banking, and with a hunch that there is something going to happen with money when I got into the bank. And I worked every job in the bank, so it's not like we learned this overnight. So it's been a long journey, and I had to be shamed by a toddler to tell me to look at Bitcoin, and then it triggered me into these things. So I wasn't that smart. I had to be pushed around a bit to find this way. And we didn't expect AI to be so seamless into our platform. We never thought of it. We just wanted a programmable ledger programmed by human beings. But we were shocked at how fast AI could do it. So anyway, thank you for that.
And thank you, Suresh. Lots more to talk about, but let's leave the conversation right now as a continuing conversation. Thank you very much.